Okay, this video tutorial looks at the mathematical strand of similarity and congruence, and more specifically we're going to focus our understanding on looking at surface area of similar figures. Okay, so we're going to look at checking if shapes are similar using surface area, or a way of identifying the surface area if shapes are similar. So if two shapes are similar, then they must be connected with a scale factor of k. We know this because we've looked at enlargement and reduction, and we've looked at similar figures. This also implies that the surface area of the shapes are connected with a scale factor of k squared. So, for example, we can find the unknown, if we want to find the unknown surface area for the similar solids here, we can see here that we're going from 9 to 6. So we actually have a k value of 6 over 9, or we can write a k value of 2 over 3. All right. So and then in order to find our surface area, we have our old surface area. All right, old surface area, and we multiply that by k squared. In this particular case, we're going to have a surface area of 72. We're going to multiply it by 2 over 3 squared. Now all we need to do is get our calculator out, punch in 72, times that by 2 over 3 all squared, and that gives us an answer of 32 centimeters squared. All right, so we're basically timesing our old surface area by the new, by the scale factor squared to get our new surface area. So here's an example question where it says the solids alongside are similar. Solid A has a surface area of 40 centimeters squared. It has a volume of 15 centimeters cubed. We don't need to worry about that too much at the moment because we're just looking at surface area. It says find the surface area of solid B. Well, we can see here that we have a scale factor of 4, okay, because we're multiplying by 4 to get to our new side. So therefore, we need to multiply our surface area by k squared. So our new surface area is going to be 40 times by k squared, which in this case is 4 squared. So we go 40 times by 16 is going to be 640 centimeters squared. Okay, so here's a practice question I'd like you to have a go at. Please feel free to pause the video. Once you think you've got the correct answer, continue the video and we'll see how you went. Here's another practice question I'd like you to have a go at. Please feel free to pause the video. Once you think you've got the correct answer, continue the video and we'll go through the answers for both of the last two questions. Okay, so we're looking here. We've got a surface area of our original shape of 100 centimeters squared, and we're looking to find a k value. We're going from here to here, so k is actually going to be 10 over 8, or if you wanted to simplify that, k is 5 over 4. So our new surface area, all right, is going to be 100 centimeters squared, or our old surface area, multiplied by our k value squared, 5 over 4 squared. All right. In that particular case, it's going to be 100 times by 25 over 16, which is 2500 over 16. And we can work that out on a calculator. 2500 divided by 16, 156.25 centimeters squared. Okay, in our last question here, we're actually trying to work out the opposite. We're not trying to work out the new surface area, we're trying to work out the length. So what we need to do here is we look at the surface areas. Okay, they're the clues we're going to be looking at. So basically, here we need to divide our surface areas. So we need to figure out how we go from one to the other. So 450 divided by 50 gives us 9. All right, remember that that is also k squared, so 9 equals k squared, because that's what we're multiplying for the surface areas. So therefore, k must equal 3. All right, so that's our scale factor. So then if we're going back this way, we can go, we get smaller, 11 divided by our k value, which is 3, is going to give us our x value, and therefore x is 11 over 3.